All right, why don't we get started? Good morning, everyone. My name is Matt Mangriotis. I'm the product manager for the PMP 450 product line. Today we're going to talk about field results using the brand new product, the 450M product, which contains the CN Medusa technology. Very exciting launch most recently with this product, and let's talk about how it's been performing in the field and where we're headed with this thing. Again, in terms of logistics, if you have any questions, I'm going to keep the lines muted in the interest of keeping a clear speech. But if you have questions, there's a question box in the webinar tool. Feel free to post questions in there. If appropriate, I'll stop during the presentation and try to answer them during. If not possible, we'll wait till the end and I'll take more questions at the end. This shouldn't be too long, so let's get started. So just in a general sense, I just wanted to make sure everyone can understand the portfolio that Cambium Networks has to offer in terms of the large product suite that we have available now. We keep adding to this portfolio to provide more and better solutions as we move forward in time. And with CN Maestro, we're now able to manage just about everything in the portfolio, certainly by next year, everything in the portfolio under one management tool, either cloud-based or on-premise-based management tool. And if you haven't tried CN Maestro, we recently released software that allows the 450 product line to be managed by CN Maestro, and it's a great free tool in order to manage and configure all of the 450, ePMP, and pilot products today. So we have everything from very long distance large backhauls, 2+ gigabit type of backhauls, down to distribution, which includes the point-to-multipoint products, the 450 line and ePMP lines. And then we now go into the home or into the local wireless LAN portions with the CN Pilot portfolio. We also announced recently the CN Reach or IIoT solution for SCADA data collection type of devices, including serial interfaces. So we have, again, solutions that can meet just about every fixed wireless need that's out there. We'll focus today on the 450 product line, which is my area of influence. And just to kind of summarize what that platform encompasses, it is the flagship PMP product family. We put a lot of effort into developing, increasing feature set, increasing capacity over time. It's really all about efficient use of spectrum and to provide the most data that we can provide in a very reliable and scalable fashion to customers. In a 20 megahertz channel, we can provide over 125 megs per access point or per sector. And with the recent increases to 30 megahertz channels and then soon to be 40 megahertz channels, we will go well beyond 250 megs per sector. And then with the 450M product, we can even show results in the 400 range. Again, all using very limited channel size, and it's all, again, about spectral efficiency. It's OFDM-MIMO based system and software defined, which means we can react to feature requests and increase capabilities in a rapid fashion versus standards-based products, which are really restricted by the ASICs that you're using. We utilize GPS synchronization, and that really allows us to minimize self-interference and allow frequency reuse in combination with the very high-performing antenna systems that are used in this platform. And we continue to evolve the platform. We started with 5 gig, and we since launched 2.4, 3 gig, 900 megahertz. We basically cover all the unlicensed frequencies that are out there. We will continue to support the 3 gigahertz range as that gets more widely used and more spectrum allocated for it under the new rules. So we are definitely planning to support those new rule sets, the CBRS in the US. We've increased modulations over time to allow higher throughputs. We've increased modulation modes to allow better link budgets. We continue to improve processing power with the 450i platform, which was introduced on 5 gig last year and will be introduced shortly on 3 gig. We are able to do more and more PPS to eliminate any issues due to packet constraints. We support large MTUs in order to support any networks that require MPLS tags or something beyond the standard 1522 type byte frame size. And we have a feature-rich QoS suite in the radios themselves, so you don't need any back-end equipment to control and manage the data that's transferred through the links. Very simple architecture. I like to point this out because in contrast to some of the other systems that are available, it's a very flat, simple architecture. It really functions as a bridge. We have an access point or a base station sector that wirelessly talks to the customer premise equipment, which is fed by a single Ethernet cable at the customer home. And that can be powered by a CN Pilot device from inside the home, which can also provide indoor Wi-Fi to that customer. In lieu of that, a separate power supply could be used. So there's some flexibility, but again, it's a very simple, flat, bridge-like architecture that doesn't require any evolved packet cores, gateways, licensing schemes, or anything else. It's a very, very simple, flat, you know what you're in for, low total cost of ownership, and very quick ROI. So we are shipping the 450Ms. The 450M was introduced and announced back in late June, and we said we'd be shipping by the end of Q3, and in the very last week of Q3 we commenced shipping. They're shipping now, and if you've ordered it, be on the lookout. They're shipping out of the factory, and we are working hard to ramp that factory production so that we can meet all the needs for these products. To cover a little bit about what the 450M is, it really is leading edge technical innovation. It provides much higher capacity than we're used to or than we had in the past. In a typical sector, we believe it delivers around 3 times the capacity of that of a 450 or 450i sector. So if you have a reasonably loaded sector out there of 450, simply replacing the access point with the CN Medusa 450M and utilizing this massive multi-user MIMO technology, we can now communicate with up to 7 subscribers at the same point in time. And on average, we believe that provides around 3 times the capacity. And we're seeing that in the results that I'll show you in just a little bit. And it's not just by doing wider channels. Really, it's about achieving really good spectral efficiency. We are able to demonstrate over 400 megabits in a 20 megahertz channel. Now, we won't see that in the field too often, but we are certainly able to demonstrate that in a lab setting to show you kind of the top-end capabilities of this product line. And that has to do with how they're spread out in the field and what the RF conditions are for each SM. But the real beautiful thing about this product is that you're protecting your investment. You can continue to use those existing 450 subscriber modules that are already in the field and enhance the overall capacity of that sector by simply changing the access point. So it's a very, very valuable proposition with this product. And some of the maybe secondary benefits, but very important benefits, are in the uplink. Our uplink is able to mitigate interference because of the beamforming capabilities of this antenna system. We really are directionally aimed at listening to specific subscribers at any given point in time. And that narrow beam kind of isolates the signal from any interference coming from any other direction. So you get a 3 to 5 dB increase in link budget simply by the beamform. And then on top of that, there's RX sensitivity improvements in the radio itself, which are in some cases 5 to 6 dB better. So we're talking, almost 10 dBs better signals in the uplink, which really helps to increase the link reliability. And in addition to all of that, this processor that's involved in this product is much more powerful than anything we've had before. It's more than 100,000 packets per second, so we'll never have a packet constraint when using this device. Smooths things out quite a bit. It's a very simple single box. It's got all of the antenna array contained within this one radome. There's nothing to connect. There's no interconnects. There's no RF cables. There's nothing to weatherproof, nothing to have a point of failure external to the device. you can use a single Ethernet cable to connect, power, and do everything there. There's a couple questions coming in, but I'm going to keep going because I will cover some of those as we move along here. Just to recap on the key features of the system. We believe in a typical deployment that you'll yield more than 3 times the throughput by utilizing this massive multi-user MIMO capabilities. Again, it's all the smart beamforming antenna array is contained, and there are no RF cables to connect. It is a 14 by 14 MIMO system, which means we can talk to up to 7 subscribers at any given point in time. It does uplink beamforming to help mitigate interference and has better sensitivity in the uplink, meaning better receive sensitivity at the AP. We can utilize those existing SMs, so you don't need to do any truck rolls on the subscriber sites. It has great processing power, so you never need to worry about overrun packets even in small packet situations where lots of small packets are transversing the link. No issues there. And there's really no replanning necessary. Because we're using that same 20 megahertz channel, capacities can increase without any change to your frequency plan. We do have multiple input-output options. We do have an aux port, which will be activated in a very soon-to-be released software that will allow you to do PoE out to power another device. And there's also an SFP port. It should you want to use optical data connection instead of the Ethernet. You would provide power through that main PoE port, but then data can go through the SFP module. And it's a wideband radio. We are covering 5150 to 5925 in a single radio. So I'll spend a minute or two talking about really what this technology is when we talk about massive multi-user MIMO. And it's really about combining several different types of technology. MIMO is the term multiple input, multiple output, really means increasing the capacity between 2 nodes by delivering data in different ways. And generally, the ways are by changing the polarity of the antenna systems. So in the case of the 450, we have a 2x2 MIMO system, which is doing horizontally and vertically polarized antennas, so two different antenna polarizations that provide different data at the same time between 2 nodes. And when you talk about massive MIMO, what you're doing is adding different types of antennas, more antenna systems and more antenna polarities in order to increase that capacity, still between 2 nodes. We combine that again with beamforming, a beamforming array, which allows us to steer the antenna energy and transmit to a specific subscriber located somewhere within that 90-degree sector. And then taking all these things together, we are now able to do that because we have multiple transmitters. We can do that to more than 1 location at the same point in time. And that's when you talk about multi-user MIMO. And by combining all these techniques, we've now, we're calling this CN Medusa technology. And to get multi-user MIMO, it's really about spatial multiplexing. What that means is that we're able to, by isolating subscribers in space, we can talk to more than one of them at the same point in time without interfering with one that's separated in space. So CN Medusa actually utilizes what's called a sounding mechanism in order to determine which SMs can be grouped together and talked to simultaneously, or spatially multiplexed. And it's all about collecting this channel state information. So the subscribers are actually reporting back to the access point what their RF conditions are, where they're located in space, and how they can actually be talked to by that access point. And every frame, the subscribers are reporting this information back to the access point, and then the access point actually determines how to group them together. So in this example that I'm showing here, I have lots of the little blue triangles, which are representing the CPE or SM equipment, and I am able to group 4 of them together in group 1, and those are the red guys. So I can talk, because they're spaced out across that 90-degree sector, I can talk to all 4 of those red subscribers at the same time slot. And then I'll switch and move to the green time slot where I can talk to 4 more. So that's what I'm showing in the example. So if that was the case, and every time slot of the frame, I would be doing about 4 times the capacity of a single 450. So in a standard antenna, it's a sector antenna that's a 90 or 120 degree antenna, and we are TDD frame, so every subscriber is allocated a piece of the frame or a time slot in the frame, and it shifts to the next one sequentially. So the antenna energy covers that entire 90-degree sector, but now I'm talking to one at a time. And that's a typical antenna array, antenna sector antenna. We also have the ability to do beamforming in the downlink so that the radio itself can aim the beam or point the beam at a specific subscriber, but again, sequentially. And the real magic of the 450M is really about MU-MIMO operation, or simultaneously forming the beam and the nulls so that they can talk to more than one subscriber at the same point in time. And the process by which it does this is it identifies which subscribers are out there, collects that sounding information, or the channel state information, and then it'll form those beams at the specific subscribers, and it can do all of this simultaneously for up to 7 SMs. So that's how this functions. And I got a question here about, is there a limit to the number of groups? The groups are limited, the number of groups, the total number of groups are limited to the amount of slots you have in a given frame. And this changes from frame to frame. So there's not a limit to the groups. The groups can be anywhere from 1 subscriber, where it's essentially not grouped, or it can be up to 7 subscribers, any number in between. And the average number of subscribers per group kind of determines your overall capacity. But every frame it'll collect this information, and one of the key pieces of information during the sounding is whether that bandwidth request from the SM is actually needed. Because if in our system, in the Canopy Mac, if there's no data that is required to be transmitted, it will not take up any of the time slots in that frame. It'll just sit idle. So it's really pretty efficient in terms of not wasting time slots on polling mechanisms or idle bandwidth requests if it's not needed. So it's a pretty efficient system in terms of that. So there's no real limit on the number of groups. It's really limited by the number of time slots we have or data slots we have available per frame. A question is, how many subscribers can you put on a 450M access point? And it's the same as you have with the 450 system, in that you can put up to 238 subscribers per access point. That is a limit right now of how many subscribers can be on there. So it's exactly the same as the existing 450. I do want to take a moment to point out that LINKPlanner supports CN Medusa, or the 450M product. And really what this means is that you can input your existing sector into LINKPlanner. You input the location of the AP and a location of all of the SMs that are in the sector. It'll give you an estimated capacity based on those data. And then what you can do is go into LINKPlanner and swap out the access point hardware. You can take that 450 out and put 450M in at the access point location, and kind of see what the expected capacity increase would be by swapping to the 450M. This is a very valuable tool, and you don't even need to buy anything, because it's available online for free. So LINKPlanner is available on our website. I encourage you, if you're considering going with the 450M, to input your sector and see what you could expect from swapping out to the 450M before you even go ahead and order one. So the meat of the presentation today is about kind of what's happening with some of the trial sites that we're doing in the field. So let's get to that. So if you, the very first trial site we installed back in June, and it was on a site. In the lower left-hand corner, you can kind of see a LINKPlanner with 2 overlapping sectors. And they had 2 60-degree overlapping sectors with about 110, 109 SMs on it. And this is replaced by a single 450M. And we did a lot of work in the maintenance window for a number of weeks to kind of work out the kinks and finish the development of the product. And what we were doing during those maintenance periods was actually testing in both sector mode and in MU-MIMO mode. And you can see in the graph there, we're pointing at the sector mode where we were seeing about 40 megs of aggregate throughput, or in the downlink rather, throughput in the downlink when we do what we call a flood test, which is available in the software GUI now on the 450M. You can flood the sector to see what your maximum capacity would be. And then when we turn on MU-MIMO and do the flood test again, we're seeing about 4 times the amount of downlink throughput, or about 160 megs. So you can see that it's not only carrying traffic in the maintenance window there, about 20 megs of background traffic. When we do those flood tests, we're actually able to show that we have a capacity of about 160 megs in the downlink. And then we flipped and turned it on completely. And it's been operating for several weeks now with really good results. So if we look at what we had prior to the swap, in the top rows there, those 2 boxes are the 2 sectors. And if you add up the total downlink in those 2 sectors, it was 26 point something and almost 27. So about 53.5 megs in 40 megahertz of spectrum, because remember we're doing 2 access points here. We replaced those 2 sectors with a single 450M using 20 megahertz of spectrum. And in the real world, we're seeing over 80 megs in the busy hour, in the evening hours, when people come back from work and turn on Netflix or what have you. We're seeing capacities over 80 megs in the graphs that I'm showing there. And since then, actually, we've had reports, we're well over 100 in this sector in the peak hours. And it's really showing that we do have additional capacity that's not being utilized yet. So there's room to add more subscribers and increase the data packages of those subscribers that are on there. So really good results from this sector. And now I'd like to talk a little bit about another site. This one is a little bit farther away, over in Italy, as a matter of fact. And we replaced a single sector with a 450M. There were 81 SMs. A couple of them were a little farther away, but most of them are pretty good range. This one was again installed back in June, and we did a lot of debug and work to finalize the development. It's been running for several weeks now as well, and it's been very clean. And what I'm showing in the bottom right-hand corner is that sounding process. We have a method of collecting diagnostics on the access point. The green dots that are the x-axis is really over time, and the y-axis is the subscriber count, if you will. So each one of the rows represents a different subscriber. And over time, the green dots are reporting a sounding receipt. The access point is receiving the sounding mechanism. The red dots is a full comprehensive sounding, which happens over time and regularly across those SMs, but not every frame. Every frame is reporting the green dot. That's called condensed sounding. And then we have the full sounding once in a while, which is those red dots that you see kind of spread across time. And what it's showing is that if there were problems, we would have a lot of gaps in those green dots, but we don't. We have a very clean process now, and a lot of the debug went into making sure that this thing is reliable, clean, performs the sounding when it needs to, and is able to take advantage of the increasing capacity. So to go through the results of this sector, before we swapped out the access point with the 450, that top graph is kind of showing a couple days over time, and we're showing about 35 megs as the capacity in the downlink. The max capacity that we hit in the downlink was about 35 megabits. And in the bottom graph, we're showing with the 450 over time, we're seeing peaks well above 90. And again, since this time, we certainly have hit over 100 megs in this sector, and we believe again that there's more capacity to be had, that the customers simply aren't stressing it out or maxing out the capacity. So really good results. And actually I wanted to point out that with that first customer, we've actually since the time of that single sector going online, they've deployed more than a dozen Medusa products at several sites and now have over 800 customers operating 100% of the time on Medusa. So it is scaling well. We are excited about the operation. It is consistent with our belief that we can achieve over 3 times capacity, and we're proving that right now. So as we speak, there's several customers that have received these products and are in the process of putting them up. I do want to point out that it's not necessarily a trivial exercise. We do have training that we're developing. There is a training course, a 1-day 450M certification training course that's available on the 29th of November. And I think it would benefit greatly those that are considering. We'll go through the considerations, when you would want to use 450M. We'll go through the installation process. How might it be different than installing a 450? What you need to consider there. We'll go through expected performance and how to model that. And then we'll go through any tips and tricks or things that other customer experiences that would have. So I encourage you, if you're able, or if you're interested, to go to our website and sign up for the 450M certification training, the very first version of this 1-day class, on November 29th. It'll be a very useful tool for a lot of people that are interested in getting going with the 450M. So that's just a plug for our training class there. And I do want to talk a little bit about where we're headed with this platform, because it's not we're not done yet. It's just been introduced, but we're already looking at how do we scale to 40 megahertz. We are planning to do wider channels. We will not do 80 megahertz, but we certainly are planning to support 40 in the near future. That'll be sometime next year. And it's really what we've determined to be kind of the max realistic channel size for, especially in the 5 gig range. We don't know of anywhere that has an 80 meg channel that's wide open and enough to make use of it. It is a future-proof platform in that we use the very powerful quad-core FPGA system on a chip, and we don't yet know where the upper limit of the capabilities are. We are where we are today, and we know we have opportunity to improve. So we're certainly doing more things with this platform. We're not only extending the life of the existing 450 SMs, but we are supporting future generations of 450 SM devices. We are planning to introduce a new wideband SM next year that will also work with 450 or 450M. And we have a commitment to replicate this technology in the 3 gig band. So we have the 3 gig 450i, which is imminent. That's coming out in the next month or two. And beyond that, we will have a 450M in 3 gig. So we will do Medusa on 3 gig as well. And we have a rich roadmap beyond that. So we're looking at how do we support non-contiguous channels. We're going to add downlink beamforming, uplink MU-MIMO. We have the ability to, because we know where everything is at in that sector, we can actively null interference in directions that aren't in the subscriber of interest. And we're considering lots of iterations on the hardware. So additional frequencies, possible new antennas, improvement in PPS, and really the goal here is to get to a capacity that's beyond 1 gigabit per second. And we believe we can do that with this architecture. And that's all I had in terms of presentation. I see some questions have come in. I will try to answer them as best I can. And if you have more, please feel free to type them in. I'm going to circle back on the questions. One question is, will the slides be made available? I don't know if the slides will be made available, but the recording of the webinar will be made available on the website, and look for that in the forum sites. And if you've signed up, I think you'll get access to that and have a link sent. Are multi-antenna subscriber units available? We don't. We have a 2x2 subscriber that's been sold since the beginning of the 450 days, and that subscriber continues to operate. We have lots of options on the subscriber side, but all of them are 2x2 MIMO. So that is the antenna that's on the subscriber side. It's a H plus V antenna system. And then another related question is, how many antenna elements are used to implement Massive MIMO? I covered that. We have 14. It's a 14 by 14 system. It's a 7-chain dual pole system. There's actually 28 patch antennas in there that are illuminated and phased in order to provide those beams of energy. Um, let's see, what are the highest speed packages of WISPs in the examples? I know one of them offers a 25 meg package to their customer. Um, I know that has a lot to do with the funding models that are supported by the government in terms of supplementary funding for some things. So they do a 25 by 3, at least in some cases. That's probably the biggest ones I've seen. I know they're trying to offer 50 as well, and they're evaluating whether that makes sense for the amount of density that they have. But typically what we see in terms of if you have a 5 gig deployment, line of sight 5 gig, and you're thinking of going out to about a 5-mile range, that sort of thing, we typically see 10 meg packages being offered as kind of the standard, but certainly 25 is possible. So that it really varies on what you're willing to accept in terms of oversubscription and busy hour and that sort of thing. So it's really up to the operator. Have we evaluated using different channels or different frequencies for the downlink versus the uplink? No, in terms of kind of like a hybrid FDD type system, no, we really haven't done that. This is still utilizing the Canopy TDD MAC layer. So we haven't evaluated that. I know that's something that some of our competitors are engaged with in terms of how they deliver more. Really, the goal here is to utilize the spectrum to the best of its ability, and it's all about spectral efficiency. We're trying to use less spectrum to do more, and so that's kind of the goal. I don't want to utilize more spectrum at the expense, attain capacity at the expense of using more spectrum. I think that's the goal here, is to use the spectrum that you're already using, but in a much better way. Any other questions I can answer at this time? If not, then I thank you for attending the webinar, and I hope to see you soon. Look for more webinars on this topic in the near future. Thanks very much for joining. This is Matt Mangriotis. I will talk to you guys later. Thanks.